So it says exponential functions and logarithmic functions are inverses of each other. And we just saw that on Desmos. They are symmetric to the line y equals x. So if you graph them, it'll look like they're reflected over the line y equals x. So we have a little formula here, and it's what he showed you in the video. And it says log base b of x equals y can be rewritten as an exponential. B to the y equals x. Now this seems really foreign to us, but it's no different than all of our other inverse operations. So this is multiplication, right? 2x equals 4. 2 times x equals 4. Could I rewrite that as a division? Yeah, I could just divide both sides by 2. And now I have x equals 4 divided by 2, right? That's the same thing. We took a multiplication problem and we wrote it as its inverse, okay? This can also happen with all of our other functions. So let's say I have the square root of x. The square root of x equals 4. What's the inverse operation of square rooting? Squaring. So if I square both sides, then I actually end up with 4 squared. So we can take a square root equation and rewrite it as a squared equation just by kind of flipping it backwards and doing the opposite, right? That's inverse functions. So this is no different. It just looks kind of weird because we're not familiar with logs. It's like a weird concept to us. But it's no different than any other inverse operation that we come across in math. So let's take a look at example 1a. It says log base 8 of 1 equals 0. So look at our little formula. So he said base to the power equals the number. Base to the power equals the number. Or if you had me in pre-AP Algebra 2, I like to call this NBC. Yeah. Remember that? So the way I remember this from high school, literally, I learned this in high school, and I still, to this day, when I'm converting to exponentials, I sing bum 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 in my head. You guys know NBC? Yes. That's like their jingle.
Oh, and you played it last year.
So like the TV channel NBC, their little sound clip is bum bum bum, like a major sixth and a third down. So for some reason, that makes me think left, right, middle, or low, high, middle is the way I think of that. So it sticks with some people. Some people are like, what in the heck are you talking about? Don't care. Do what you want. Okay? If you can remember it, then do what you need to do. So this would be 8 to the 0 equals 1. Left, right, middle. Okay? And does that make sense? 8 to the 0th power equals 1? Yeah, anything to the 0th power is 1. Okay, so example B, what's my base? What's the base of the log? 2. The base of the log stays the base of the exponential. So 2 to what power? Negative 4 equals the number in the middle is 116. Now it should make sense to you. The problem that you just set up should make sense. So what does a negative number do to what does a negative exponent do to a number? It takes it under. So this becomes 1 over 2 to the 4th. And what is 2 to the 4th? 16. So yes, it makes sense that 2 to the negative 4th is 1/16. So if you rewrite it and the exponential doesn't make sense, you probably rewrote it wrong. Okay, so now we're just going to go backwards. So take a look at 2a and b. Try and do those backwards on your own real quick. If you need to look at the little thing at the top, that's fine. Backwards is a little bit. Very rarely will you see log base 10 written as log base 10. That's actually just it's just log by itself. If it's not written, it's assumed that it's base 10, kind of like that little video said. In other words, kind of like the same as a square root. We don't write it, but what root is a square root? It's a 2 root, right? They don't write the 2, it's just assumed if it's not there, it's a 2 root. Same concept. The 10 is most commonly used, so if it's not written, it's a 10. And then this one over here, log base 9 of 3 equals 1/2.
Mr. Stark?
Yeah.
A little on your recording thing.
Okay, so now on your calculator, go ahead and open up your calculator. For examples A, B, and C here, I want you to actually use the math function for the log. So the way you'll do that, you'll hit the math button. And then if you scroll up, it's a letter A. So hit enter, and that allows you to type in a log base other than 10. So our first one here is log base 2 of 8, and that gives us 3. Equals 3. Now, why does it equal 3? Let's think of that using NBC and rewrite it as an exponential. Let's see if our equation makes sense. Left to the right is what? 2 to the third should equal 8. And it does. 2 times 2 times 2 is 8. Okay, and then your calculator, the next one. So math up. And then log base 8 of 2 is, let's write it as a fraction. What's 0.3 repeating? Yeah, it's 1/3. So equals 1/3.
Which is 3.
So if you rewrite this, that's 8 to the 1/3 equals 2. Earlier this year, we had those rational exponents. What is the raising something to the 1/3 the same thing as?
Raising it to a
Yes.
negative first.
The cube root.
Cube root, obviously.
And what is the cube root of 8?
2.
2. Yeah, the one that we see more commonly is 1/2. So 4 to the 1/2 is actually the same thing as the square root of 4, which is 2. So 1/2 is a square root, 1/3 is a cube root. Now this one, do we need to use the math menu?
No.
No, what's the base of C?
10.
It's 10, and there's a button for that. It's just this one right here. This one here is log base 10. So you can just type in log of 20, and you get that ugly number. So I'll say it's about 1.3. But this is a good example of why we use logs. It's much easier to write log 20 than this, right?
Yes.
It's how we compare really ugly numbers, really long numbers, really small numbers, really big numbers. So logs are used, this is a really good example for a scenario like this. Okay. Example 4. It says evaluate without a calculator, but what I mean by that is don't use the log button. You can use your calculator, but don't use the log button. So what I mean by that, let's rewrite this as an exponential. So this equals something. So 2 to the some number equals 64. So you can use your calculator to kind of check and guess 2 to the 4th, 2 to the 5th, 2 to the 6th. But I don't want you to actually use the log button. Okay, so do A, B, and C real quick and come up with those answers.
6.
6. 2 to the 6th power, so 6 is your answer. What about B?
5.
3 to what power is 243? 5.
5.
And what about this one here?
4. No,
16 to what power is 4?
Why?
1/2. In other words, the square root of 16 is 4, so 1/2. So, real quick, you guys, what happens if we have inverse operations in the same equation? So let's say I have x plus 2 minus 2 equals 4. What happens when I have inverse operations next to each other? They cancel. And I end up with x equals 4, right?
Yes.
Well, the same thing happens with logs. If you ever have, you guys look up here. If you ever have an exponential base raised to a log of the same base, your answer is just x. They're inverses of each other. They cancel out. And same thing happens vice versa. If you have a log base of the base, same base of an exponential, the log base and the exponential base cancel, and you're left with x. So these are a couple shortcuts. If you just memorize them, it'll make things really easy for you. So I have log base 6 of an exponential base 6. What's going to happen? Those cancel, and my answer is 8. And you could check that in your calculator. You could do log. So I'll go to my math math up, is log base A. So log base 6 of 6 to the 8th, and it tells you it's 8. So you can verify that on your calculator. Same thing here. I have the base of an exponential raised to a log of the same base. Those cancel, and I'm left with 4x minus 1. I don't know what x is, so we just leave it as that. But so now we can use exponentials to actually help us solve. This is an equation now, right? We haven't technically had an equation up to this point yet. So what we can do is use NBC, or we can call it left, right, middle, whatever you want to think of. That we can use that little shortcut to rewrite it as an exponential and solve. So how could I rewrite this equation as an exponential? 4 to the 5 halves equals x. Just by doing that, we basically solved the equation, right? X is by itself now. Whatever the left side comes out to is my answer. So in your calculator, you can do that if you want. So 4 to the 5 halves is 32. So my answer, x equals 32.
Wow.
We just solved the log equation. What would b be? 10, because log base 10, to the right side equals the middle. So 10 to the 4th equals x. Just by rewriting it as an exponential, I basically solved it. So what is 10 to the 4th? 10,000. So therefore, x equals 10,000. And I'm done. So hopefully you realize that these two are the same decimal, right? And these two are the same decimal. So what we basically need to figure out is, how do I get from this number and this number to this number? We multiplied, right? And 4 times 5 is 20. So who can summarize the rule? If two logs are added together, we can combine them, or we call it condense them, into a single log and do what to the two numbers? Multiply them. So A times B. Same thing on the next set. Hopefully you realize that these two are the same. These two are the same decimal, and these two are the same decimal. So how do I get from 10 and 2 to 5? And how do I get from 18 and 6 to 3? They divided. So if I ever have two logs that are subtracted, you can write them as a single log, but divide the first number by the second number. How many of you got that? Good? Now the one on the back is maybe not quite as obvious. If you didn't get there, that's okay. But these were the same and these were the same. And then it gave you a little table that was kind of a hint. Who thinks they can summarize what happens when I have a number multiplied in front of a log? Scott?
So if it's going to be b log a, it's going to be the number. I mean the letter b.
So what happens to the number in
So
front?
a log b, it's going to be an exponent to b.
Good. It becomes the exponent of the number in back. So this would be log of b to the a power. So on your notes, real quick, for the last things for today, go ahead and copy these properties into your notes from earlier. So you'll see the exact same chart. Go ahead and copy these properties down. And just be aware that this can happen both ways. All of these happen both ways. So if I have like log of 50, how could I break that apart into two logs? What operation is going to be in the middle of them? Technically, we don't know, but let's say there's a plus in the middle. What are some options for what our logs could be? If they are added together, what was being done? Multiplied. So what times what is 50? You could do 10 and 5. Is there another scenario? 25 and 2. We don't know. It can be either. So I can do log 25 plus log of 2. So this is how you would go backwards and break it back out into two separate logs. That's called expanding. So bunching them